Assalamualaikum warahmatullahi wabarakatuh. My name is Nadia Farahin binti Rosli. I'm from RAF 2016A. I present my thesis about modeling of cytopylus or age structure using multivariate analysis. First, we will dive in chapter 1. Background of study. Rice is a staple meal for more than half of the world population and is found in more than 100 nations. We are still accounting for 90% of worldwide production according to the Nelly et al. In 2016. Along with the massive production of the rice in the warehouse, we face with cytopylus aureus, which are the most destructive toxic insect pests in the world, according to Prakash et al. In 2021. As a result of their behavior, life cycles, and habitat in the rice storage, the commercial value for the rice decreased also with the seed germination, while the fungal infection increased. As for the problem statement, widespread pesticide use increase the pesticide resistance, cause human harm, pollutes the environment. Insect pest management, IPM proposes a holistic approach to pest control that tries to optimize the use of variety of ways to manage a wide range of pests within a specific farming system due to the danger of pesticide. These studies offer various morphometric characteristics of cytopylus aureus gathered from 3 to 6 months and be observed by week for the age, structure measurements, and morphological measuring capabilities. It is important to know the age structure of cytopylus aureus because by knowing them, we can control the cytopylus aureus population in rice warehouse as we know at what age they started to infest. As for the research questions, first, will the cytopylus aureus detect in between the weeks affecting the whole statistical analysis? Second, why we should control the variables in logistic regression of cytopylus aureus? Third, does the least measurement of cytopylus aureus influence the whole morphological analysis? Fourth, does the morphological analysis for the age structure of cytopylus aureus using logistic regression will be different if using another type of rice? And last, does the gender of cytopylus aureus influence the modeling of cytopylus aureus age structure through multivariate analysis? This research can enhance more knowledge regarding the modeling of cytopylus aureus age structure using multivariate analysis for the agriculture and help the rice industry in controlling the destruction caused by these insects. In this study, there are three objectives. First, to evaluate age of cytopylus aureus based on morphological structure. Second, to analyze morphometric analysis based on logistic regression by week. And third, to make use of morphological analysis on cytopylus aureus based on weekly measurement on age structure. This study is going to cover regarding morphological analysis, statistical analysis, and also the main focus which is the prediction of cytopylus aureus age using logistic regression model. As for the limitation, we are lacking of time for this study, which result in not so much statistical measure analyzed could be done for better confirmation of overall model fit. Next, we will proceed with chapter 2. Weevils of the rice plant cytopylus aureus are among the most damaging pests of grains, seeds, and grain products stored in elevators and also bins. Rice can have irregular shaped holes. Weevils are migrating upward from disturbed grain store. The ability of infected seeds to germinate keeps decreasing. Weevil damage to rice result in subpar rice. A yield loss of 10 to 100% will occur if not controlled. Anis and Morton in 1997 found that all life stages of cytopylus aureus died when exposed to 15 to 100% carbon dioxide at 25 degrees and 60% of relative humidity. Nakakita et al. In 1987 looked at the effect of low temperature on cytopylus aureus and found that at 10 degrees Celsius, each species hatching and metamorphosis were inhibited. At 15 degrees Celsius, cytopylus aureus population growth was completely halted. Adults develop from pupil exposure at 40 degrees Celsius with a very high frequency of sterility. As for the life cycle of cytopylus aureus, adults live a long time, several months to 1 year. Eggs are laid during this majority of a female's adult life, while up to half of her eggs are laid in the first 4 to 5 weeks, and each female can lay up to the 150 eggs. Next, we move with chapter 3, methodology. Pack and addition on regular basis to ensure that the cytopylus aureus grew properly. As for the morphological analysis, a total of 20 adults of cytopylus aureus were collected and be observed for 8 weeks. The body length, body width, prothorax width, thorax width, head width, and rostrum width, and also the rostrum length of cytopylus aureus were measured using the stereo microscope. All the measurements were observed observed in millimeter and recorded in table of Microsoft Excel by weeks. As for the statistical analysis of heterophilous origin method, the data measurements recorded in Microsoft Excel, then the statistical analysis were running to generate the average, standard deviation, and also the correlation based on the body measurements and weeks. And the last method, which is also the important one, prediction of heterophilous origin age through logistic regression model. The age of heterophilous origin was predicted using all of its physical characteristics. The age by week data was analyzed using the logistic regression model in Excel step to determine the relationship between the multinomial response and the collection of explanatory factors, including the morphological characteristic of heterophilous origin. In this work, 20 of heterophilous origin were used for the model development. 3 different models were tried. Model 1 is made up of combination of body weight and head weight with traits. Model 2 only includes the thorax width and rostrum length, while the Model 3 only includes prothorax width and rostrum width. The overall fit of the model was evaluated using the methods of logistic regression as a measure of classification accuracy. Next, we go to Chapter 4, Results and Discussion. The result for morphological analysis. The pictures here shows the morphological analysis of heterophilous origin, including the body length, body width, prothorax width, thorax width, head width, rostrum length, and the morphological was used to determine the age. Morphological structure of heterophilous origin in the picture shows from the top view and also the bottom view. Acted in 2018 estimate the length of adult reviews to be between 3/32 and 1/8 inches, about 2 to 3 mm. Adults are dull reddish brown to black with 4 light reddish or yellowish patches on the elytra and round or irregular form peaks on the thorax. 1 mm long or about 1/3 of the length is the snout. The prothorax or the elytra are equal in length to the head with snout. The elytra feature rows of peaks within longitudinal groove and the prothorax, according to the Davis in 2003. The larvae live inside the groin canals hollow, legless, and humpback shell. The pupae resemble adults and have large snouts, although they are white. The table in this slide shows the average size of adult heterophilous origin recorded. From the table, we found that adult male and female average lengths were 2.9 mm up to 2.8 mm respectively. This means that the heterophilous origin grew well and standardized with the average size of adult heterophilous origin. In this slide, the table shows the correlation of body measurement for the heterophilous origin. The correlation of body length, thorax width, head width, and rostrum width were in positive correlation by weeks. These were the correct one as the growth rate should be positive along with time. On the other hand, body width, prothorax width, and rostrum length have negative correlation by weeks. This must be errors in the data because supposedly the correlation should be positive as the measurement of heterophilous origin by weeks increase and indicate the growth rate. Errors that could be occur are such transcriptional error. When information is inaccurately written down or recorded, transcription error occurs, according to the Wahi et al. In 2008. Examples of this include the comparing numbers inaccurately or skipping number when entering data from a datasheet into a computer application. Probably during recorded the measurement data in Excel, a few measurements were recorded wrongly, then affecting overall statistical data analysis. Here, the table shows the regression model overall statistical measure of gender prediction in heterophilous origin. Based on how well each statistical metric performs overall, model 1 that has consists of body weight and head width respectively has greater chance of correct percentage of classification compared to model 2 and 3 that much lower in the percentage. However, supposedly for the best perform model to use to measure the more accurate age structure of pseudovirus origin should be more than 70% for the correct classification validation sample. As for this experiment, the best yet was achieved only about 30% for the correct classification, training and validation sample of the model, which means that many errors have happened during this experiment was run. The errors that could be happen from the experiment was from the software that been used in Mesh J, which played a big role in measure the pseudovirus origin that used for calibrate, measure and analyze the morphological structure of the rice reveal. Some image of the pseudovirus origin and scales could be distorted, so then the image J has read the wrong calibration of the image and so recorded wrong measurement. Next, we proceed with the last chapter, chapter 5, about the conclusion and recommendation. In conclusion, as for this study, the best model that achieved for predicted the age of pseudovirus origin has been determined to be model 1, which model using model body width and head width. This decision was made based on the overall performance on each statistical measure. It was at least successful in correctly classifying pseudovirus origin based on the age about 30% of the time. However, it was not reliable as it was expected to be, but as in this study, that was the best achievements so far. Further study and trial should be done in depth to achieve the expected correct classification so that the model could utilize efficiently for better use in the future. The created model will be useful for measuring the overall age rate and for the sake of agriculture and to assist in reducing the damage these insects cause into the food storage. Along with that, this model could be used to evaluate age of pseudovirus origin based on morphological structure through logistic regression based on measurement on its structure. It is recommended that other methods should be tried for the modeling of pseudovirus origin in future, such as discriminant analysis and support machine, as both of them also involved in statistical method and also classification method.